Now, before we move on, let's do a quick recap of what we've done so far. Right? So far, what we've done is we have learned what a random variable is. Then we talked about probability distributions, right? And what need to be true for any probability distribution. And then we learned how to compute the expected value and the variance of any random variable. Now, the fact of the matter is there are many different probability distributions out there, but there are some common ones that show up a lot in many applications. And so what we're going to do now is we're going to start looking at some common probability distributions in the real world. Okay. Now, the first one that we'll look at is what's known as the binomial probability distribution. The binomial probability distribution is associated with the binomial experiment. So let's talk about that first. So the binomial experiment is an experiment that satisfies four conditions. The first condition is that there must be n trials. So there are n trials. The second condition is that each trial must have two outcomes. Third, the probability of each outcome is constant across all trials. And then fourth, the trials are independent. Okay, which means that what happens in one trial, in any given trial, right, does not affect what happens in any other trial. Okay. So if an experiment satisfies these four conditions, then it's known as a binomial experiment. Okay. So let's look at an example and determine if we have a binomial experiment or not. Let's say a student takes 4 classes of the same difficulty pass-fail basis. If we assume that the four classes are independent, do we have a binomial experiment? Right? So assuming independence of the four classes, is this a binomial experiment? So to answer this question, what we want to do is we want to check whether the four conditions of a binomial experiment are met. So let's go ahead and do that. First off, do we have n different trials? The answer is yes, right? So the student is taking four classes. So think of each of the classes as a trial, and so we have four different trials. Next, do we have two outcomes for each of the trials? The answer is yes, right? Because here the four classes are taken on a pass-fail basis. So the student either passes the class or he or she fails the class, right? So there's no letter grade A, B, C, D, or F. So we have two outcomes, which are pass and fail. Right? Next, we want to ask ourselves whether the probability of each outcome is constant across all trials. In other words, is the probability of passing the same for all four classes? And then is the probability of failing the same for all four classes? And the answer to these two questions are yes, right? So the answer is yes and yes. Why? Because we're assuming that the classes are of the same difficulty, right? So you have the same probability of passing the first course or second course, and so on and so forth. And then we need the trials to be independent, which is one of the assumption, right? So we have independent trials. Okay, and so because all four conditions are met, we do have a binomial experiment in this example. All right. Now, one thing I want to note about the third condition in particular is that what we require here is that the probability of each outcome is the same across all trials. Right? This does not mean that the probability of the outcomes have to be equal. So this does not mean that probability of outcome 1 equals the probability of outcome 2. For example, it's entirely possible that the 4 classes that the students take are super easy, right? So if the probability of passing is say 0.9 and the probability of failing is 0.1, this is still a binomial experiment as long as the 4 classes are of the same difficulty. Okay. Now, if the courses are not of the same difficulty, then you have the probability of passing being different for each of the courses. Then we no longer have the a binomial experiment because the third condition is not met. So in this video, we talked about the concept of a binomial experiment, and we looked at an example of a binomial experiment and how one of the requirements may be violated.